Here we are going to study the IC engine. So the first module is introduction, where we're gonna study the basics of the IC engine. So the first is engine. The device which transforms one form of energy into the another form is called as engine. Normally, most of the engines convert thermal energy into mechanical work, and therefore they are called as heat engine. Heat engine can be broadly classified into two categories. The first is internal combustion engine. The abbreviation is IC engine. Next is external combustion engine, and the abbreviation is EC engine. The external combustion engine are those in which the combustion takes place outside the engine, whereas in internal combustion engine the combustion takes place within the engine. For example, in a steam engine or a steam turbine, the heat generated due to the combustion of fuel is employed to generate high pressure steam, which is used as a working fluid in the reciprocating engine or a turbine. This is an example of external combustion engine. While in case of a gasoline or a diesel engine, which is also an internal combustion engine, the product of combustion generated by the combustion of fuel and air within the cylinder for a working fluid. So the next is engine component. So even though the reciprocating internal combustion engine look quite simple, but they are highly complex machines. There are hundreds of the components which have to perform their function to produce the output power. There are two types of engine which I already mentioned. First is the spark ignition engine, next is the compression ignition engine. Let us discuss the important engine component. So the first thing in the engine component is cylinder block. So here you can see this is the cylinder block. So the cylinder block is the main supporting structure for a various component. The cylinder of a multi-cylinder engine are cast as a single unit called as cylinder block. The cylinder head is mounted on the cylinder block. The cylinder head and cylinder block are provided with the water jacket in the case of a water cooling. Here the water cooling water is there. This is the jacket. So the bottom portion of the cylinder block is called as a crankcase. So this part is a crankcase. The inner surface of the cylinder block, which is machined and finished accurately to the cylindrical shape, is called as bore or a face. So the inner surface of cylinder is this one. This diameter is called as a bore diameter. It's highly finished. Next is the cylinder. So as the name implies, it is a cylindrical vessel or a space in which the piston makes a reciprocating motion. The varying volume created in the cylinder during the operation of the engine is filled with the working fluid and subjected to a different thermodynamics processes, which I will discuss later. So the cylinder is supported in the cylinder block. So the next is piston. So this is the piston. So it is a cylindrical component fitted into the cylinder, forming the moving boundaries of a combustion system. It fits perfectly into the cylinder, providing a gas-tight space with the piston ring and the lubricants. So the next is, this is the ring which is there in the piston. So the next is combustion chamber. This place is called as combustion chamber. So the space enclosed in the upper part of the cylinder by the cylinder head and the piston top during the combustion process is called as a combustion chamber. So the piston top to the cylinder head, this is called as a combustion chamber. So the next is inlet and exhaust valve. These two valves are the inlet and exhaust valve. So the valve are commonly mushroom shaped poppet type. Here you can see it is a poppet type structure. So this is the poppet type. So they are provided either on the cylinder head or on the side of the cylinder for regulating the charge coming into the cylinder. So while coming into the cylinder, it's called as inlet valve, and for a discharge, the product of combustion is exhaust valve from the cylinder. The next is the spark plug. Here you can see the spark plug is at the head of the cylinder. So it is a component to initiate the combustion process in the spark ignition engine and is usually located at the cylinder head. Next is the connecting rod. So this part is the connecting rod. So it interconnects the piston and the crankshaft and transmits the gas forces from the piston to the crankshaft. So the next is crankshaft. So this particular part is the crankshaft. So it converts the reciprocating motion of the piston into the useful rotatory motion of the output shaft. Next is the piston ring. So this particular part is a piston ring. So the piston ring fitted into the slots around the piston provide a tight seal between the piston and the cylinder wall, thus preventing leakage of the combustion gases. The next is the camshaft. The camshaft is there at the top. So the camshaft and its associated parts like a valve spring and rocket arms and all. So it controls the opening and closing of the two valves. Next is the cam. The cam is here, just below the camshaft. So these are made as a integral part of the camshaft and are designed in such a way to open the valves at the correct timing and to keep them open for a necessary duration. So this is all about the engine components. So let's move to the next topic. The next topic is 4-stroke spark ignition engine. So in a 4-stroke engine, the cylinder of operation is completed in a 4-stroke of the piston or the 2 revolution of the crankshaft. During the 4-stroke, there are 5 events to be completed. The first is suction, second is compression, third is the combustion, fourth is expansion, and fifth is the exhaust. Each stroke consists of 180 degree of a crankshaft rotation, and hence 4-stroke cycle is completed through 720 degree of the crank rotation. The cycle of operation for a ideal 4-stroke SI engine consists of 4 strokes. The first is the intake or suction stroke, next is the compression stroke, and another one is the expansion, and last is the exhaust stroke. Now let's discuss one by one in detail. The first is the suction or intake stroke. So suction stroke starts when the piston is at a top dead center and about to move downwards. The inlet valve is open at this time and the exhaust valve is closed. Due to the suction created by the motion of the piston towards the bottom dead center, the charge consisting of air-fuel mixture is drawn into the cylinder. When the piston reaches the bottom dead center, the suction stroke ends and the inlet valve closes. The next is the compression stroke. The second stroke is the compression stroke. So the charge taken into the cylinder during the suction stroke is compressed by the return stroke. So during this stroke, both the inlet and exhaust valves are at the closed position. Here you can see both the inlet and exhaust valve are at the closed position. So the mixture which fills the entire cylinder volume is now compressed into the clearance volume. So the clearance volume here is the volume when the piston moves from bottom dead center to the top dead center, then the remaining volume is called as a clearance volume. Okay, so this is the complete cylinder volume and this is clearance volume. So the mixture which fills the entire cylinder volume is now compressed into the clearance volume. At the end of the compression stroke, the mixture is ignited with the help of a spark plug located at the cylinder head. Here this is the spark plug which is located at the cylinder head. Once the piston is compressed to this end, the spark is going to generate through the spark plug. In ideal gas, it is assumed that burning takes place instantaneously when the piston is at the top dead center, and hence the burning process can be approximated as heat addition at a constant volume. During the burning process, the chemical energy of the fuel is converted into the heat energy, producing a temperature rise of 2000 degrees Celsius. The pressure at the end of the combustion process is considerably increased due to the heat release from the fuel. Now the next stroke is the expansion stroke, or it is also called as power stroke. The high pressure at the burned gases forces the piston towards the bottom dead center. After compression, the piston is at a top dead center. Now the burned gas is going to force the piston towards the bottom dead center. So both the valves are closed position, and during this stroke the power is produced and both pressure and temperature decreases during the expansion. So the last stroke is the exhaust stroke. So at the end of the expansion stroke, the exhaust valve open and the inlet valve remains closed. Here you can see the exhaust valve is open and the inlet valve remains closed. So the pressure falls to the atmospheric level. A part of the burned gases escapes. The piston starts moving from a bottom dead center to the top dead center. In last stroke, the piston is going to move from bottom dead center to the top dead center and sweeps all burned gases out from the cylinder almost at atmospheric pressure. The exhaust valve closes when the piston reaches the top dead center. At the end of the exhaust stroke, some residual gases trapped in the clearance volume remain in the cylinder. So these residual gases mix with the fresh charge coming in during the following cycle, forming its working fluid. A cylinder of a 4-stroke engine completes the above 4 operation in a 2-engine revolution. The one revolution of the crankshaft occurs during the suction and compression stroke. Here suction and compression stroke consist of one revolution, and the second revolution during the power and exhaust stroke. The second is the expansion or power and exhaust stroke. So thus for a one complete cycle there is only one power stroke while the crankshaft turns into 2 revolution. So this is all about the 4-stroke spark ignition engine. So now let's discuss the PV diagram of the 4-stroke spark ignition engine. So as I told, the first stroke is the suction stroke, where the air fuel mixture is going to suck inside the cylinder. So in this stroke only the volume is going to increase, but the pressure and temperature will be constant. The next is the compression stroke. Here you can see the 1 to 2 stroke is a compression stroke, where the air fuel mixture is going to compressed. So it results in the increase in the temperature and pressure. So next is the process 2 to 3, where the combustion takes place and a lot of heat is going to generate, which results in the increase in the temperature as well as the pressure. So 2 to 3. Next is the expansion stroke. It is also called as a power stroke, where the piston is going to move from top dead center to the bottom dead center. Next is 4 to 5. Here the drop in the pressure and temperature takes place. And last is the exhaust stroke. In the case of a exhaust stroke, the burned gases is going to move out from the cylinder. So this is all about the PV diagram of the 4-stroke SI engine. So the next is 4-stroke compression ignition engine. The 4-stroke compression ignition engine is similar to the 4-stroke spark ignition engine, but it operates at much higher compression ratio. The compression ratio of an SI engine is between 6 and 10, while the CI engine it is from 16 to 20. Here the compression ratio of CI engine is more. It's because, let's firstly talk about what is compression ratio. The compression ratio is the ratio of the volume of the cylinder to the clearance volume. As I already told, this complete volume is a volume of cylinder, while once the piston reaches from bottom dead center to the top dead center, then the remaining volume is called as a clearance volume. So the compression ratio is the ratio of volume of the cylinder complete volume of the cylinder to the clearance volume. Also, the compression ratio is inversely proportional to the clearance volume. So in SI engine, the clearance volume is more. In SI engine, the clearance volume is more compared to the CI engine. That is why the compression ratio of CI engine is less, which is 6 to 10, while CI engine is more, which is 16 to 20. Now in the CI engine, during the suction stroke, the air is inducted. Only in CI engine the air is going to come inside the cylinder. Due to the high compression ratio employed, the temperature at the end of the compression stroke is sufficiently high to self-ignite the fuel which is injected into the combustion chamber. In a CI engine, a high pressure fuel pump and an injector are provided to inject the fuel into the combustion chamber. The carburetor and ignition system is necessary in the SI engine, are not required in the CI engine. In detail, I will explain later on what is carburetor and how it works. But here in SI engine, as like in SI engine, we used air fuel mixture, so to give the proper amount of the air fuel mixture, the carburetor is required. But in the case of a compression ignition, the carburetor is not required because only air is going to inducted inside the cylinder. So now let's discuss each stroke in detail. So the first stroke is the suction stroke. In suction stroke, air alone is inducted during this stroke. During this stroke, the inlet valve is open and the exhaust valve is closed. Here the inlet valve is open and the exhaust valve is closed. Next is the compression stroke. Air inducted during the suction stroke is compressed, means the piston is going to move here from bottom dead center to the top dead center. So both the valves remains closed during the compression stroke. Here you can see both the valves are remains at the closed position. The next is the expansion stroke. Fuel injection starts nearly at the end of the compression stroke. So once the piston move from top dead center, bottom dead center to the top dead center, the injector is going to inject the fuel. So the rate of the injection is such that the combustion maintains the pressure constant in spite of the piston movement on its expansion stroke, increasing the volume. After the injection of the fuel is completed, the products of the combustion expand. Both the valves remains closed during the expansion stroke. Last is the exhaust stroke. The piston traveling from bottom dead center to the top dead center pushes out the product of the combustion. The exhaust valve is open and the intake valve is closed during this stroke. So here we can see the PV diagram of the CI engine. So the first is the suction stroke, where the air is going to suck inside the cylinder. That's why it is at the constant pressure and temperature while the volume is going to increase. Next is the compression stroke, where the air is going to compress. Here the air is going to compress, which causes the increase in the temperature and pressure. And just after the compression, the injector is going to inject the fuel, so which causes the combustion. So because of the combustion, the rise of temperature and pressure will takes place. That is here, this is the ignition point. The fuel air mixture ignites and the rise of the temperature and pressure takes place, and after that the lot of heat is going to generate, which is going to push the piston from top dead center to the bottom dead center, and it's called as expansion, so which results in the decrease in the temperature and pressure. And last is the exhaust, where the burned gases are going to escape from the cylinder. So this is all about the 4-stroke compression ignition engine.